Okay, in this video I'm going to continue on with exercise 4B of the book Fundamental Applied Mathematics. We're on page number 107 and the question is number 26. It reads, a boat has to travel by the shortest route to a point 4.25 jhat kilometers and then return immediately to its starting point at the origin. The velocity of the water is 8 root 2 I hat minus 8 root 2 j hat, and the boat has a speed of 18 kilometers an hour in still water. If a I hat plus b j hat is the velocity of the boat on the outward journey, find a and b, and also the time taken for the outward journey, and using surd format. So let's just sketch the motion first. So we draw our Cartesian plane, then draw where the point the ship is going to travel to. So it's 4.25 j. So that's a position vector, of course. All right. So next we talk about, we know the velocity of the water is 8 root 2 I minus 8 root 2 j. So it's plus I minus j. So we'll say this is VW 8 root 2 I minus 8 root 2 j. Alright? Next, the velocity of the boat, or the speed of the boat, excuse me, in still water is 18 kilometers an hour. So that of course corresponds to VSW for reasons I've discussed ad nauseum at this stage. So that's equal to 18. Alright, now what direction must it go? If we want the actual boat to go VB to go in a northerly direction, then we must take out the x component of our water vector, we'll say our water vector. So that means we need to go in a negative x direction but a positive j direction. So it's going like that. I'm going to call this angle here theta. Alright, and this is going to be VSW, whose magnitude is equal to 18. Alright, and we know of course that VSW is equal to 18 times negative 18 times the cos of theta I positive 18 times the sine of theta j. Alright, now we're told that if ai at plus bj at is the velocity of the boat on the outward journey. Well, like if it's on the outward journey, then of course b is going to, or a is going to be equal to 0, because the velocity of the boat is going to be, we'll say, 0 I hat plus bj hat. Right, that's the first thing. So let's just continue on anyway, because that's kind of trivial, to be honest. So let's plug all the values we know into the fact that VSW is equal to VW, or VS minus VW. Alright? Let's get rid of this, and let's write the following. You say VSW is equal to VS minus VW. Like so. Therefore, we know that negative 18 times the cos of theta I hat positive 18 times the sine of theta j is equal to the velocity of the ship, or say the velocity of the boat. Why am I using s? VB, which is 0 I hat plus bj hat minus 8 root 2 I minus 8 root 2 j. Like so. Alright, well of course we just need to work at the I component first this time, because it's 0 here, so that means that 18 times the cos of theta I, that's negative 18, is equal to negative 8 root 2 I. Therefore the cos of theta is equal to 8 root 2 over 18, and theta is equal to the inverse cosine of that. So let's go 8 divided by 18 multiplied by root 2, inverse cosine that answer. Theta is equal to 51 degrees. Alright, so how does that help us? Well, if we look back up here, we know that positive 18 times the sine of 51 is equal to b plus 8 root 2. Therefore b is equal to 18 times the sine of 51 minus 8 root 2. Now, it wants to even third form something, to be honest, I don't like doing, but I'm just going to have a look at the answer in the back of the book. So 4b, question 26. So 14 minus 8 root 2. So let's just check out what 18 times the sine of 51 is. Yeah, so that answer is correct. Alright, that answer there is correct. So next what we're asked to do, we need to, the boat has to go back to where it started. Alright, so look, if you want to know exactly how we're going to do this, look at questions 25 and 26 when we did the exact same thing. However, this time all it's going to change is the velocity of the ship relative to the water. Alright, and the velocity of the boat. The direction of the boat is going to change to a southerly direction, like so. And we need to get rid of the I component again. So it's going to be like this. That's going to be VSW. So it's negative I, negative J. So just change this here to a negative sign. And everything else is going to stay the same. So everything else is going to stay the same. So, and we know of course that the angle is equal to 51 degrees. So just going to deal with the Ji component this time. So 18 times the sine of 51 is equal to B plus 8 root 2J. Therefore B is equal to minus 18 times the sine of 51 minus 8 root 2, and that's all in the J hat unit vector direction. Well, of course A remains to be 0. So I'm just going to put this into the calculator. 18 times the sine of 51 is 14. So let's check this at the back of the book. So 4B question 26. What was the second part of this question? Find the time taken for the outer journey only. Okay, then it says also find the time taken for the whole journey. So we need to find the time taken for the whole journey. Okay, so let's find the time taken for the whole journey. Right, so this is the velocity vector for the return journey. Alright, now the distance is equal to 4.25 J. Alright, so it's a distance of 4.25, which is in a j-hat direction, so it must be divided by a velocity in the j-hat direction. So we know that this here, now of course it's a negative direction, but it's going to be a positive velocity, so it's just going to be 18 times the sine of 51 plus 8 root 2. That's a positive number, okay? And that's going to be equal to, say, T1, or T return. And T outwards was equal to, if I remember correctly, it was 4.25 divided by 18 sine 51. This time it was minus 8 root 2. Okay, so all that doesn't confuse you. It's just that we've done these things so many times that this stage you should be reasonably comfortable with dealing with these. So we just need to add the two of these vectors, which to be honest is something I just really don't want to do. So it says we need to find the total time. Okay, so let's just do this. It says it's supposed to be 1 3/4 hours first of all. Okay, I'm just going to put these into decimals because I really don't want to do this. Okay, so you have 4.25 divided by 18 times the sine of 51 plus 8 root 2. Just be careful with your brackets. That turns out to be 0.167. Alright, then we have 4.25 divided by 18 times the sine of 51 minus 8 root 2. Be careful with your brackets. That turns out to be 1.58. If you add the two together, 1.58 plus 0.167, you get 1.75 hours, which is 1 3/4 hours, which is correct. Alright, 1 3/4 hours, which is correct. I personally don't like dealing with surds. I kind of find them pointless. So anyway, that's the answer. It's pretty straightforward. It is correct. So thanks for watching. Please pass it on to your friends and subscribe to my channel.